AI, machine learning, generative AI, these terms are absolutely everywhere, right? They're in the news, they pop up in your meetings, they're all over your LinkedIn feed. And a lot of the time they're used in ways that make them sound like they all mean the same thing. It can feel like you're just supposed to know what they are, but let's be honest, the definitions get fuzzy really fast.
And that's a super common problem. If you ask 10 different people what AI actually means, you are probably going to get 10 different answers. Is it a self-aware robot from a movie? Is it just another word for ChatGPT? Well, that confusion isn't on you. It's what happens when marketing hype takes over. Our whole goal in this explainer is to cut through that noise.
So before we go any further, let's just get one thing on the table right now. AI is not magic, it is not a personality, and it is definitely not a sentient being. At its core, AI is a huge field of computer science that's been built up over decades on a foundation of math, data, and statistics. Our job here is to strip away all the sci-fi stuff and give you a clear, grounded idea of what these powerful tools really are.
So, here's our game plan. First, we're going to set up a simple framework to make sense of these terms. Then, we'll use it to decode the 6 most common concepts you'll hear. After that, we'll connect all the dots to show you how they fit together. And we'll finish up with the key takeaways you'll want to remember for your next conversation about it.
Okay, so to make sure we're adding clarity, not confusion, we're going to use a really simple, repeatable framework to look at each of these terms. Think of it as our mental anchor as we move through this.
For every single term, we're going to ask the same 3 questions. 1, why does this thing even exist? What problem was it designed to solve? 2, what does it actually do? What's its one main job? And 3, what does it not mean? What's the biggest misconception we need to clear up? Using this structure is going to make all of this way easier to digest and remember.
All right, with our framework ready to go, let's get into the heart of it. Time to start decoding the 6 foundational terms, and we're going to move from the most general concept all the way down to the most specific.
First up, the big one. Artificial intelligence, or AI. So why does this term exist? Well, for decades, computer scientists have been chasing this goal of building machines that can do things that normally require human smarts. Things like reasoning, problem solving, or perception. AI is simply the name for that entire field of study.
So what's its job? To simulate intelligent behavior for a very specific task. The best way to think of AI is as the giant umbrella that covers everything. This includes old-school, rule-based systems like IBM's Deep Blue, the computer that was programmed with chess rules to beat a grandmaster. And it's really important to know that pretty much all AI today is what we call narrow AI. It's highly specialized for just one thing. Now, what it is not is a sentient, self-aware robot. That's the biggest misconception out there.
Now, that old rule-based approach had a huge problem. You can't write a rule for every single possibility in the real world. I mean, just imagine trying to write an if-then rule for every spam email that could ever exist. It's impossible. And that brings us to machine learning, or ML. It exists specifically to solve that problem by completely flipping the script.
Its core function is to find patterns directly from data instead of being fed explicit rules. Your email spam filter is the perfect example. Nobody programmed it with a list of scams. It learned to spot junk by analyzing the statistical patterns in millions of emails that people like us marked as spam. So what it does not mean is that the machine thinks or understands. Your spam filter has no idea what a prince or a lottery is. It just knows that emails with certain word patterns are statistically very likely to be junk. It's all about correlation, not comprehension.
But what happens when the data gets way more complicated? Traditional machine learning started to hit a wall when faced with massive, messy datasets. We're talking billions of images, audio clips, and videos. And this is exactly where deep learning enters the picture. It exists to handle that incredible scale and complexity. Its main job is to use a special structure called a neural network, which has lots and lots of layers to find really complex patterns in raw data. This is the tech that powers facial recognition on your phone or the voice recognition in your smart speaker. But here's what it's not. It's not an artificial brain. That word deep isn't philosophical, it's structural. It literally just means there are a large number of layers in the mathematical model. That's it.
Okay, this brings us to the term you're probably hearing every single day, generative AI, or GenAI. This exists because researchers wanted to go beyond just analyzing or classifying data that already existed. They wanted to tackle the much bigger goal of creating brand new, original content. And this was a huge shift, from just perceiving the world to actually creating things in it.
Its core function, believe it or not, is to generate new stuff by predicting the next most likely thing in a sequence. When ChatGPT writes an essay, what it's really doing, on an incredible scale, is just predicting the most probable next word, over and over and over. Now that leads us to what it's not. It isn't creative in the human sense of the word. It doesn't understand the essay it's writing. It's a phenomenally sophisticated mimic, putting together words based on the patterns it learned from all the human-written text it was trained on. The result feels original, but the process is pure statistics, not sentience.
Okay, last two terms, and these are absolutely critical if you're looking at this from a business angle. Training and inference. These terms exist to describe the two different stages in an AI model's life. Training is like studying for a test. It's the huge, computationally expensive process where the model learns from data. It's done once, offline. Inference, on the other hand, is like taking the test. This is when the finished model gets put to work applying what it learned to new problems in real time. It happens over and over, every single time you use the tool.
Okay, we've defined our 6 core terms. Now in Section 3, let's just take a second to snap all the pieces together and see how they relate to each other.
The easiest way to picture the first 4 terms is like a set of Russian nesting dolls. Artificial intelligence is the biggest doll. It's the whole field. You open it up, and inside you find machine learning, which is just one way to achieve AI. Open that one, and inside is deep learning, an even more powerful type of machine learning. And a key use for deep learning today is generative AI, which uses those deep networks to create new content. Each one is a subset of the one before it.
And what about our last 2 terms? Well, training and inference describe the life cycle of any model that's built with this tech. Think of training as the build time. It's that massive, expensive, upfront effort to create the model's knowledge. Then you have inference, which is the usage time. This is where the model's knowledge is basically frozen, and it's just applying what it learned to your prompts. This becomes an ongoing operational cost.
So after all that, what should you really walk away with? In this last section, let's boil it all down to the 3 most important takeaways for any professional trying to make sense of the AI landscape.
If you only remember 3 things from this entire explainer, make it these 3.
Number 1, generative AI is the user interface. It's the part you interact with, but it's not the intelligence itself. The real magic comes from the massive deep learning model that was pre-trained and is now working behind the scenes. Number 2, the difference between training and inference is what drives the economics of AI. Training is a huge upfront capital expense. Inference is an ongoing operational cost. Understanding that difference is absolutely crucial for any business strategy. And number 3, keep your eye on what's next. The big shift we're starting to see is toward agentic AI. Moving from models that can just generate content or talk to models that can be given a goal and then take a series of actions to achieve it. In other words, models that can act.
So at the end of the day, these terms all describe incredibly powerful tools, not magic boxes. They're all grounded in math and data, and understanding them clearly is your best defense against the hype. To keep you thinking, I'll leave you with a few questions to chew on. How might that shift to agentic AI change complex business workflows in the near future? How does that difference between training and inference costs really impact a company's strategy? And how are companies using AI that can understand more than just text, like images, audio, and sensor data, to create something new?